So our first topic that we're going to cover today is looking at the static traffic assignment in Visum. So we're going to take a look at, all of the objects that are required to run static assignment, and then the different options within those assignments. So as part of that, we're going to take a look at the following workflow. So the first part we're going to take a look at is preparing the network and making sure we have all of the objects and everything set up. And from there, we're going to take a look at adding in the demand options into the network. And then from there, we'll look at all of the different parameters associated with that static assignment. And then finally, going ahead and adding in that procedure for the assignment and performing that analysis. All right, so as part of the network preparation, the very first thing we have to start off with are the transport systems, modes, and demand segments. So these are all tied together and represent the different vehicle types and options that will be traveling throughout the network. From there, we'll take a look at all of the different network objects. So this will be things like the links, the nodes, and the zones. And then also looking at the volume delay functions and the generalized costs that are going to be used to feed into that static assignment procedure. So all of these transport system modes and demand segments, so these are kind of all grouped together. The transport systems are the kind of overall option here in this hierarchy. So in here, and like for this example, we have a couple of different private transport system options. So in this case, we're looking at car and heavy vehicles. And in Visum, the transport systems will be abbreviated as TSys. So you'll see the word TSys or TSysset quite a bit in Visum, especially in the network objects. So for example, the links and the turns will have different transport systems allowed over those objects. And then you can also set up a public transport system as well. And then from there, these will be comprised of different modes. So for the private options, so like for car and heavy vehicles, this will just be a one-to-one mapping. So we'd have a car transport system and a car mode. But for the public transport, this is where we can set up different modes. For example, you might have buses or trains or other public transit options in your network. Each of these are then mapped to one or more demand segments. And these demand segments are going to be used to tie the origin destination matrix demand to the network. So for example, for the cars, you might have a couple of different options. You might have, a private car or business car matrix. You could also have different, matrices for time of day if you wanted to split those up, like if you're looking at maybe an AM peak and a PM peak. And yeah, again, all of these will be hooked up to the demand matrix, which we'll look at a little bit later. So all of these options are going to be found underneath that demand tab up at the top. So that very first option will have all of those options listed out: transport systems, modes, and demand segments. And within this window here, each of the options will have a different tab. And so you can select each of those, and then over on the right-hand side is where you can create and edit and add all of the different options that you want to have in your network. All right, so now we have our vehicles kind of set up and ready to go. So the next part is going to be taking a look at all of the different network objects. So in Visum, the first object is going to be looking at nodes. So you'll want to make sure that you have nodes added at all of the intersections and any location where vehicles need to make a decision. So for example, at any of the freeway on-ramps or off-ramps, or even at any locations where you might have a change in link behavior. So for example, if you had along the freeway, maybe you have an additional lane or a decrease in lanes, you can add a node there and then update the different link behaviors for each of those. You can also do this if you wanted to also adjust the link speed. And then each of these nodes are going to be composed of different turn values, so all of the allowed turns within the node. And then those links are going to be used to connect each of those nodes together. All of the demand itself will be placed onto the network through the zone object, and the zones are going to be linked to the network through connectors. So these are kind of all of the base network objects that are required for just setting up any basic assignment in Visum. And these can either be, of course, added in from scratch if you just wanted to build up a network, but there's also a lot of options for importing other networks as well. So if you did have like a Vistro network or a Visum A&M file, maybe from running dynamic assignment over there, you can also import those as well as from other platforms. Another great option is also like importing this from OpenStreetMap. This will build in a lot of like the base network for you, and then you can make additional edits from there. All right, and so as part of the static traffic assignment, there are a few different attributes that are really going to be taken into account for that assignment procedure. So for links, they will all have a type number associated with them, and this type number is going to be linked to a volume delay function. And we'll talk about all of the different volume delay functions set up in a bit. And then also on links, again, this is where that TSYS or TSYS set is allowed. So this is where you can choose which transport systems can travel over all of your links. So for example, you might have a one-way road, so you'd want to turn off those transport systems. Or if you had maybe a car-only road or just bus-only road where you wanted to just set that to certain modes, you can do that all through that TSYS set attribute. And then the link length is going to be used to calculate the free flow travel time in the network. This will be automatically calculated by Visum when you do add in a link. And then also the capacity will be used to determine the volume capacity ratio, which will then lead to that congested travel time calculation. And then V0 is going to be used as the free flow speed, which will also be used to calculate that free flow travel time. And then on the turn side, very similar to links, these also have a volume delay lookup associated with that type number that's set. You can also turn on or off, again, those transport systems. So for example, if you wanted to maybe turn off all of the U-turns in your network or disallow certain turns, you can click that TSYS set button here, and then this will allow you to update those values. The turns also have a capacity associated with them that you can set, as well as a T0 value, which is really the base delay. The T0 can also be used as kind of a turn penalty option. So if you run your assignment and if you notice maybe vehicles are taking a way that that maybe is not quite aligned with maybe some of your count data or field data, you can apply a turn penalty to just kind of deter vehicles and add some additional base delay to that turn so that they will take a different route to reach their destination. And then for the nodes, those also have another volume delay function lookup associated with the type number, as well as the capacity and base delay. And the nodes and turns are kind of unique. We'll talk about that next, but which delay option gets utilized will be based on the node setting for the volume delay function. All right, so moving over into those volume delay or VDF functions there. So these are going to be used to calculate the attribute here, which is called TCurve. So you'll notice this value can be seen on the links and on the turns. And this really represents the travel time in the loaded network. And then from here, this will also be used to calculate the impedance in the network, which is going to be used as part of the traffic assignment process. So again, for most of these objects, this TCurve value is going to be based on a lookup table that's going to reference a particular volume delay function, again, based on that type number that's set for each of those objects. And all of the setup for this is going to be underneath that calculate menu, underneath general procedure settings. So the first one here is for links. So if you click on the drop down here for the PRT settings, this is kind of where we're going to be living for the next couple minutes here. So the links VD functions is where all of the link volume delay functions are held. So at the very top, in this top portion of the window, this is where all of the link types will be listed out. In this case, this is this model just has a single link type, but if you had additional ones, maybe for different arterial roadways or parking lots or freeways, all of those would be listed here. And then over on the right-hand side is where each of these types get tied to a VDF function number. And all of the volume delay functions will be held down here in this lower window. And so this is where you can either edit the existing function, or you can create and add additional functions and the related coefficients. And then for nodes, this is where there are a few different methods that can be used. So if you click under node impedance here, you'll see the standard method is going to be set to the turns VDF. So this is one that's going to, again, utilize all of the turn information. So it's important to make sure all of those are set up correctly with the correct types. This dropdown will also allow you to switch this, so you can either use a node volume delay function or use the node intersection capacity analysis method. So for the turns, this is very similar to the links, where you just have all of your turn types here listed in the top, and then each of those associated with a volume delay function number. Now, Visum will also create a few of these by default, so you'll have your right, straight, left, and U-turn automatically created. And all of these are actually just going to reference, by default, just the single volume delay function, which is going to look at that T0 value. And then for the nodes as well, these also have, again, a type number associated with them, and then that corresponding volume delay function. And again, this will only get used if the node impedance method has been selected to be nodes VDF. And this will kind of show you down here too, with this little warning if that is not selected as the default method. And then finally, if instead you didn't want to use that one of those lookup tables for the turns or nodes, you can use that intersection capacity analysis, or ICA method. And this will allow you to set up different methods for each of the different intersection types. And then finally is the connectors also have a volume delay function. And these are only going to be considered for connectors that have are set up to be like a percentage or share connector from the zones. And so this is really going to be utilized if a zone had maybe multiple connectors leading it into the network. And so this is not set up by type. It just has a kind of a standard volume delay function for those. And so you can always edit that by selecting that edit button on the right-hand side. And you can change what type of function to use as well as the coefficients. All right, so from here, all of those, again, those volume delay functions are going to calculate that TCurve value, that loaded travel time. And this is then going to be used to calculate the impedance in the network, which is going to be used in that static assignment process. So this impedance is calculated based on this generalized cost function. And this information is also stored, again, within that PRT settings, this time underneath the impedance option. And in here, by default, it's just going to be using a uniform impedance function for each of the different object types. So in this case, for links, connectors, and turns. And if you click the function button here, this will open up this other window, which will show you that the impedance is going to be calculated based on that TCurve value. And so this can be used if you wanted to create more detailed functions. You can add additional attributes and related coefficients. You can also check that in detail button if you wanted to define different functions for each of those different object types. All right, so now that we have all of the necessary network objects set up, now we're going to take a look at actually adding in that origin destination demand so that those trips can be added into the network. So all of the demand is going to be held within an origin destination matrix. So if you look on the left-hand side where that network object toolbar is, there's going to be a matrices tab down here at the bottom. And if you select that, this is where all of the matrix data is stored. To add a new matrix, up at the top, if you click that plus button, this will allow you to create a matrix, and you can add in the name and the code. And then by default, it's just going to create a standard zone matrix with based on the zone dimension, so based on the number of zones you have. So from here, once that's generated, a new matrix will show up down here in the drop-down. And you can see in this case, we just have a small 11 by 11 matrix, so we just have a total of 11 zones. And this is where you can update all of the values for those. So you can copy these in from another format. You can also import any MTX or FMA files that you have and just to use that demand within this matrix. Another nice option in Visum is all of these settings over here on the right-hand side, where you can also perform additional matrix math. And so if you wanted to apply any factors or update any of those values, you can do that very easily for all of the values within the matrix. All right, so we have our matrix created. Now we kind of have to close the loop and go back to those demand segments we talked about at the beginning. So in order for the demand segments to be hooked up with the corresponding matrix, if you go to the demand dropdown up at the top and then select that second option, that demand data here, this is where you can choose the matrix to be associated with that demand segment that you've added. So in this case, we just have a single car matrix associated with, in this case, we're just looking at an AM, a couple of hours between 7 and 9. But this is where, if you had additional demand segments, those would show up in this list, and then you can select the corresponding matrix for each of those. All right, so now we have our network and our demand. So now it's time to actually take a look at the different static traffic assignments. So there are quite a few options here. We do have a lot of different equilibrium options. The default one is just this plain equilibrium one up at the top. And this is just going to be a path-based equilibrium assignment that's going to distribute the demand and try and equalize out the impedance across all of the alternative routes between those origin-destination pairs. There's also an equilibrium BLOST method, and this one more starts with like an all or nothing assignment where all of the demand gets assigned for each OD pair will be assigned all on one route at the beginning. And then over each iteration, drivers are going to use information they gathered on their last journey for their upcoming route search. There's also a linear user cost equilibrium assignment, and this kind of connects all of the origins and destinations together at the beginning and then assigns demand over several paths at once. And because of that, since it does start out with all of multiple options at the beginning, this is one of the faster conversion methods. And then finally, for the equilibrium assignments, there's also a Frank-Wolf assignment. And this one tends to move a lot of the volume towards more of the shorter paths in the network. And then there's also an incremental assignment. So this essentially takes the demand and then divides it into several smaller matrices. So essentially you'd start off with assigning maybe 33% of your demand in the first iteration, and then the next iteration you'd have maybe 66% or so on. So you'll just kind of add that up over time until you've reached 100%. And so it kind of just more loads the network throughout each of the iterations. And then there's also a stochastic assignment, and this is more suited for any networks that don't have a lot of congestion, or if you're also modeling any non-motorized modes. All right, so we've reached our final step here, and so now we can actually take a look at setting up this assignment procedure and then running that in Visum. So all of the calculations in Visum are going to be held within this procedure sequence window. And so this is found underneath the Calculate menu. And in this window, over on the right-hand side, is where you can click the Create button to add in any of these procedure options. So in this case, when we're just doing a regular static private transport assignment, underneath the assignment folder is a PRT assignment option that we can select. And then from here, underneath the reference object is where we can select that demand segment. So again, this is going to pull in that demand matrix that's associated with that demand segment, and use that demand when running this particular procedure. And then also underneath the variant option, this is where you can choose one of those different methods. There are going to be some other methods as well that we didn't talk about today, but those are mostly for dynamic assignment. And then each of these also have additional parameters that you can adjust. And once you have all of this added, you can click this edit button over here to further refine and update any of those parameters. So once you have that added and everything set up, then in order to run that assignment, you'll just press that green play icon up at the top, and it will run through and provide you with any messages, and then it will let you know once that assignment is done and fill in the duration column here. And so then one other option, once that assignment has been run, you can review some information about the assignment. If you select underneath list, if you go to statistics and then PRT assignment quality data. So in here, this will give you information about the number of iterations that were run before convergence was reached. It will also tell you information about like the number of routes, the overall impedance in the network, and then also give you information about the convergence down here in this gap column, which will basically take that weighted volume difference between the vehicle impedance in the network and the hypothetical of vehicle impedance. All right, so now we can go ahead and take a look at an example, just running through and using one of these, the static equilibrium assignment. So I will pull that one up here. So this network may look familiar to you all if you joined us for some of the Visum DTA ToolTips episodes. So this is actually a network that we started in Visum, and then we brought this into the Zoom and then kind of further refined it in here. Since we had set that up for DTA, we had all of our nodes in place and everything. So you'll notice here we've got nodes for all of the intersections, and then also along the freeway at any location where we have any sort of on or off ramps, and then at any locations as well where we might have a lane addition or lane drop. And then also for the links, in this case we just have the car transport system selected. So here's where you can easily change and update the transport systems that are allowed if you needed to change those. And you'll notice in this case we have two separate links on the freeway. So if I select the opposite direction here, we have turned off all of those transport systems for those directions. And in here we just have, again, our single car matrix that we've brought in. We just have 11 zones, and within that demand, underneath that demand data option is where, again, we set up that matrix connection. So if you select that matrix button, this will allow you to either choose the matrix directly, or you can also set up to choose the matrix by properties and enter in a formula in this window as well. All right, so in this case, we just are running just the regular equilibrium assignment. Again, we just selected that car demand segment down here. And then if I click the play button here, that will run through and calculate that assignment result. And in this case, this has some default link bars set up. And so this is just going to be looking at the volume attribute. So in this case, if I select a link over here in the quick view window, there'll be this vol vehicle PRT, and this will be the number of vehicles that were assigned to this particular link during that assignment. And then again, we can also view some of the information about the assignment result, and that's underneath that statistics menu under list. And then if you click the PRT assignment quality data, again, this is where you can see the number of iterations that were run, and then you can also check that convergence. Now this model is very small and doesn't have a ton of options for vehicles to travel in between. So this one does converge relatively quickly and only after 3 iterations.